Let's analyze and solve the longest palindrome coding problem. We are given a non-empty string S. The string contains lowercase and uppercase English letters, and we have to return the longest possible palindrome that can be formed by using the letters from the string S. A palindrome is a word that reads the same backward and forward. From the coding perspective, what we have to do is we have to write a function. We can call it longest palindrome. The function will receive one argument, which is our string S, and has to return the length of the longest palindrome we can form from the string S. We are also given a set of constraints. What we can see is that the string is never empty. The size is always greater than or equal than 1. And once again, the string only contains lowercase and uppercase English letters. And that's the entire problem. To solve that problem, we could start from a naive brute force approach. And what we could do is to create all possible subsets from the characters in the string. If the string has n characters, the number of such subsets would be 2 to the power of n, because for each character it can be included or it cannot be included. So for the n characters, this gives us a 2 to the power of n as a number of sets. This is similar to a binary number that consists of n digits. Each digit can be 0 or 1. So the total number we can construct from a set of digits is 2 to the power of n. So this is similar in the case when we think about sets. So we could build 2 to the power of n different sets out of those characters. And then for each of those sets, we could check whether we can form a palindrome. So it would be another times n operation. So the time complexity for this solution would be really bad, exponential time. And this is not even something worth implementing. It would work only for extremely small strings. And if we try to submit this on LeetCode, we would get a time limit exceeded. So let's try to think about a better solution. In order to find a better solution for this problem, let's first notice that we are not being asked to return the longest palindrome. We are being asked to return the length of the longest palindrome. And this is important detail. Now let's look at our example string and let's count the letters. So we have 2 letters A, 5 letters B, and 3 letters C. So there are an even number of A's, so this is even, and there are odd numbers of B and odd. And let's keep this in mind, and let's now try to build our palindrome. So I will draw a vertical line. This line is a symmetry line that goes through the middle of our palindrome, and let's start creating our palindrome. So we can put letter A on the left side, letter A on the right side. We can pick another 2 letters, put B on the left side, put another B on the right side. We can pick another pair of B's, B here and B here. And we are left with a single B, which we cannot put either at the beginning or at the end, because it would make our string to be not a palindrome. So let's for now skip over that letter B and continue with C. We can pick a pair of letters C, and we can put C here and C here. And we are again left with a single letter C. So what we can notice that those leftovers come from the letters which had an odd number of copies in our original string. So we used all the letters except 2, and there is no way we can put any of those letters on either of the sides. There is only one place when we can put one of those letters, and it is in the middle. So if I pick C and put C in the middle, I can create a longer palindrome than the one I already have, and it's gonna be C in the middle, A, B, B, C, and here A, B, B, C. So this is the longest possible palindrome. We used all the characters except single letter B, and we noticed that there were two odd numbered letters, and we could use one of them but not both of them. And this is the basis of our improved algorithm. We now have a deeper understanding of the problem, and we can use this to come up with a better algorithm, since we noticed that if we have an even number of letters, those letters can all be added to a palindrome. But if we have an odd number of letters, only one odd number letter can be used in the palindrome. If we have more than one, then the rest we cannot use. So what we can do, we can pre-scan the string and create a frequency map, in the sense that we will count how many times a given letter appears in the string. So let's do that. Let's create a map. A map will have a char and int. So the key will be a character and the value will be integer, which is the frequency or how many times the character appeared in the string. And we can process starting from the beginning. So we have A, we initialize to 1, we have another A, we increase to 2, we move to B, B, we have one B, so B1, we have another B, we increase to 2, we have another B, we increase to 3, we have another B, we increase to 4, and we have the last B, we increase to 5. So we're basically counting the letters. And for C, we will do the same. We will end up with the value 3, because we have 3 letters C in our string. And once we have this map created, we can start processing the map to come up with the final answer. And let's call the answer max length. And we also need to know if there were any odd numbered letters in the map. So let's have a flag for that, is odd. And let's start from the value false. And max length, we start from the value 0. And we are processing our map now. So we start from the first key. And what we will do, we will add a value for that letter to the max length as long as it is an even value. If it is an odd value, we will add one less than that value. So let's go and show the example. So for 2, we will add 2. Max length would change to 2. B is 5. So we can only add 4. So 4 plus 2 is going to be 6. But since it was odd, we are going to mark it and change the value of our flag to true, because we found an odd numbered letter. And for C, we will again add 2, because we cannot add 3, we can only add 2. So it's gonna give us 8. 6 plus 2 is 8. And the flag is already set to true. So we don't have to do it, otherwise we would set the flag to true, because this is again odd numbered letter. And our answer is now 8. And the 8 is the final result, but we have to account for the fact that if there is an odd numbered letter, like in this case we had a C, we can add one letter to the final result. So the final result is going to be something like if is odd. So if is odd is true, then we will return max length plus 1, else we will return max length. The time complexity of the map-based solution is of n, where n is the length of our string, because we have to read the entire string, and the space complexity is of 1, and this is because we are only dealing with 52 letters, both upper and lower case English letters as per the problem constraints, so we can have only up to 52 entries in our map. And that's the entire map-based solution and its complexity. We could slightly improve our solution by using an array instead of a map. So the main idea of frequency counting, which we used in our map-based solution, remained unchanged. The difference is that we are using an array instead of a map to do the counting of how many times a letter appears in the string. And what we could do, we could have an array of length 52, so from 0 to 51, and we could use the first 26 entries to count the frequencies of the letter A to Z, capital letters, and the second half to count the frequencies of the letters A to Z, the lowercase letters. And this would be the only change. We can come up with some smart mapping that if the letter is capital A, it goes to the first slot. If the letter is capital B, it goes to the second slot, and so on. We will show it in the code, but the main idea is that we are not using map and using a less complicated and more performant data structure, which is an array. And besides that, nothing would change. Our time complexity would still remain O of n, because we have to read entire string, and the space complexity would also remain O of 1. And this is the idea how to improve our map-based solution by using an array. There is another way to solve this problem, and in this solution we start from computing how many letters appear in the string odd number of times. So in our example, there would be two letters, B and C. We can say the odd counter equals 2. Now, once we know that, we can return the result using the following logic. If our odd count equals 0, that means that all the letters in our string appear even number of times, so we can use them all in our palindrome, and we can simply return the string size. Otherwise, we have at minimum one letter that appears at odd number of times, possibly more than one. But in the palindrome, all letters must appear an even number of times, except possibly one letter in the middle. So what we will return in this case is string size minus our odd count. So we subtracted all the letters that appear odd number of times, but since we can use one of them, we just do +1. And that's the idea for the solution. Now the question is, how can we compute that odd count number? And for that, the solution is to use a set. So let me write the string again. We have a string, and we will introduce a set. It's gonna be a set of characters. And we will process the string using the following logic. For each character in the string we are processing, we are going to check whether this character is in the set. If it's not there, we are going to add it. So we are adding A, and we are moving to the next character. And the second rule is we check if the character is in the set. If it is, we are going to remove it. So we will remove A from the set. And we will continue. We move to the B. We add B to the set because it wasn't there. We move to the next B and we remove it. And so on. We add B to the set. And since it is now there, when we move to the next B, we are going to remove it. And we have the final B. We add the B to the set. We move to C. C is not in the set, so we are going to add this. We have a second C. C is in the set, so we are going to remove it from the set. And when we move finally to the last C, C is not in the set, we are going to add this. And what we did is that we ended up with a set that contains the letters B and C, and these are exactly the letters which appear in the string an odd number of times. It is because the operation adding and removing is basically nullifying the two letters that appear an even number of times. So what is left in the set are the letters that appeared an even number of times. And now we can go to our previous solution and say that odd count equals our set size. And we just computed the number of letters that appear in our string an odd number of times. And then we will write the logic for this part and just return the value. And that's the entire solution. And the complexity of this solution is, again, the time complexity is O of n, because we have to read the string. And the space complexity is O of 1. Again, we are dealing only with the 52 English alphabet letters. And that's the solution that uses set. Let's write the code for our solutions, starting from the one that uses map. So we need to define the map. We have defined the map where the key is a character and the value is integer. And we will use this map to store the information about the frequencies of characters in the string s. So let's now populate this map. So we process the entire string and increase the values in the map for each character in the string. Let's now define two variables, our result length, and we will also have a Boolean flag, let's call it hasOdd, which will indicate whether we found an odd occurring letter in the string. Now, since the map is populated, we are going to process the entire map and adjust the length depending whether the value in the map is odd or even. So in the above loop, we are processing the entire map, and when we are using a for range loop on a map, like in this case, we can use structured binding to extract the key, which is our character, and the value, which is the count, and have them as a separate variables. So in general, when we are using for range loop, the variable is a pair, but this construct uses the C++ structure binding and makes the code easier to write. And the logic inside the loop is as follows. If the count is even, we add entire count to our result. If the count is odd, then we add count -1. And we also mark that we found a letter that occurs odd number of times. Now we have to return the result. So if we found an odd letter, we have to increment the length because we can use one of those letters in the middle of the palindrome. And then we can just return length. And that's the entire algorithm. Let's try to build it. It builds okay. Let's try to run the tests. And all the tests are passing. So we successfully coded the algorithm that uses a map. Let's write the code for the solution that uses an array. For this solution, we will need a function that will map our character into the index inside the array. So I'm going to write a small utility function. The function will take a character as an argument, and that character will be an English letter, either small or uppercase, so lowercase or uppercase. And we will first check if the letter is an uppercase letter. And if it is an uppercase letter, we will return a value between 0 and 25 simply by subtracting a code of the letter A from C. And if it is not a uppercase letter, it has to be lowercase letter as per our constraints. So we will do the same, except we will shift the result by adding 26. So the counters for the lowercase letter will be stored in the second half of our array. And that's our function that translates a character into its index inside the array. So let's now define an array. So we are defining an array of 52 slots, each is integer, and we are initializing all the elements inside that array to zeros using C++ universal initialization, the curly braces at the end of the array name. So let's now populate this array with the frequencies of the characters which are in our string S. So what we did, we used a for range loop, and for each character in string S, we incremented the counter, and the index for this character was computed using our utility function IDX. So let's now define two variables. One will be our result. Let's call it len. And we will also have a Boolean flag. We will name it hasOdd, which will indicate whether the string has a character that has an odd number of occurrences inside that string. So now with the array populated, we just have to process the entire array and adjust the length appropriately. And we are going to use modulo 2 division to check whether the value inside the array is odd or even. So if the value is even, then we add the value to our result. And if value is odd, then we have to subtract 1 from the value and add this to our length. And we will also have to set the flag. Now we are ready to finalize our algorithm. First, we have to check if there was any letter that appeared in the string an odd number of times. If there was, we can use one of them and put it in the middle of our palindrome. So if there was such letter, we will increase the len by 1, and we can return the len. And that's the entire algorithm. Let's build it. It builds okay. Let's run the tests. The tests are passing, so we have successfully coded the algorithm that uses an array. Let's write the code for the algorithm that uses set. And as a reminder, the idea is that once we process all the characters in the string S, the set will contain the characters that appear in the string odd number of times. So let's start from defining the set. So we have a set of characters, and let's now process the entire string using a for loop. And the logic is that we have to check whether the current character is already in the set. If it is, then we have to erase it. If it's not there, we have to insert this to the set. So the above code is doing what we just said. We are going through each and every character in the string, and we are checking if the character is in the set. If it's there, then we are removing it from the set. If it's not there, we are adding it to the set. And let's now compute the final result. So our odd count, which is the number of letters that appear in the string as an odd number of times, is simply the size of the set. And if the odd count is 0, we return the size of the string because all letters in the string appear an even number of times. Otherwise, we return the size of the string, but we have to subtract the count of the characters that appear an odd number of times, which is the odd count. And we have to add 1 to that because we can use one of those letters. And that's the entire algorithm. Let's try to build it. And let's see if the tests are passing. All the tests are passing. So we successfully coded the algorithm that uses set. Let's make sure our solutions are passing LeetCode tests. So we are starting from the solution that uses map. Let's see if it works. It works. Let's submit it. We were able to submit. So let's now try the solution that uses an array. Let's see if this solution works. It works. Let's submit it. We were able to submit. So let's now try the final solution that uses the set. Let's see if it works. It works. Let's try to submit. We were able to submit. So all our solutions are passing all LeetCode tests. This is the end of this solution. The source code is available in the GitHub repo shown on the screen.